Okay, again, there are more than one way to do this problem. Any way you do it should go pretty fast. It should just take a few steps at most. So, left-hand side, 1 plus cotangent squared theta. That looks kind of like an identity. You might think, okay, Pythagorean identity, because there's this squared here on this cotangent, there's this 1 here. And you might be able to look that up on your list of identities, and it's going to be in there. I'm going to take a look at the right-hand side. Because cotangent, we know, is cosine over sine. So cotangent squared, we know that we can write as cosine over sine squared. Secant, you know, is 1 over cosine. So secant squared can be written as 1 over cosine squared. So what we have is cosine squared over sine squared times 1 over cosine squared. Well, you'll notice that since everything is squared, those cosines are just going to cancel. And you're going to be left with 1 plus cotangent squared equals, and we just have a 1 over sine theta squared. Of course, 1 over sine is just cosecant, so we have 1 plus cotangent squared equals cosecant squared. Look that up in your list of identities and it'll be on there. Let's try that a different way. Okay, so you might notice that there's a cotangent squared, you might notice there's a cotangent squared theta in 2 different terms. So you might think to yourself, oh, maybe I can put those terms on one side of the equation and factor out a cotangent squared. Maybe, I don't know. So maybe what you would do is you would subtract the cotangent squared from both sides. And that's perfectly fine. Of course, you did this so that you could factor out a cotangent. If you factor cotangent out of the first term, you're left with the secant squared. Out of the second term, you're left with a minus 1. Now, secant squared minus 1, is that anything? Well, if you look at your Pythagorean trig identities, you'll notice that it's actually equal to tangent squared. The form that we usually write it in, I believe, is 1 plus tangent squared equals secant squared. If you subtract 1 from both sides of that equation, you get that one right there. So secant squared theta minus 1 equals tangent squared theta. Okay, so let's plug that in. Well, you might notice right off the bat that cotangent and tangent, they're reciprocals of each other. So you might notice right away that this is true. If you don't, then all you have to do is write this thing out in terms of sine and cosine. Cotangent is cosine over sine. That whole thing is squared. Tangent is sine over cosine. And that whole thing is squared. Now again, you might notice right off the bat that these things just cancel. If you don't, the reason that they cancel is because you can distribute that square through the parentheses because you have division and multiplication and no addition and subtraction. So we can distribute that square to get cosine squared over sine squared. We can distribute this square over here to get sine squared over cosine squared. And now you should notice everything on the right-hand side cancels. 1 equals 1, check mark. Great. Let's try a different one. Let's see, I have written here cosecant squared, say x, minus cotangent squared x over secant squared x equals cosine squared x. again, hit pause, see if you can do it on your own. You're going to have to do these on your own on the test anyway. So try it out, see what happens, and come back, hit play, and I'll show you how to do it. Okay, again, a couple of really quick and easy ways to do this problem. What you'll notice is there are a lot of squared trig functions, so you're thinking Pythagorean identities right off the bat. Everything is x. There aren't any 2x's or anything like that in the problem, so we should be pretty set to go. One thing that I might think of doing is getting rid of the denominator. To do that, we multiply both sides by secant squared. If we do that, the secant squared cancels from the left side, and we get it multiplied on the right side. Now, cosine squared times secant squared, these are things that you should be starting to recognize. Cosine and secant are reciprocals of each other. In other words, I'm just going to copy down the left-hand side. In other words, secant we can write as 1 over cosine. And since we had secant squared, we can write it as 1 over cosine squared. Now you'll notice right away that those cosines cancel, and you just get 1 on the right-hand side. Now is cosecant squared of x minus the cotangent squared of x equal to 1? Well, you were thinking Pythagorean identities. So look at your Pythagorean identities. Look for the one that involves a cotangent and a cosecant. Move the terms around, and you'll see that that's true. That is just a Pythagorean identity. Another thing that you could do with this problem, another way to do it, is to notice right off the bat what we noticed in the last step of our first version of this proof. We noticed that cosecant squared minus cotangent squared equals 1. We got that from one of our Pythagorean identities. So I'm just going to plug that in. Cosecant squared minus cotangent squared equals 1. That's a Pythagorean identity. We moved a couple of terms around, but it is true. So I'm going to replace the numerator here with a 1. And we have 1 over secant squared x equals cosine of x. Well, of course that's true. Secant and cosine are just reciprocals of each other. If it's not clear right away why that's true, you could always write the left-hand side like this. Left-hand side we can write as a big parenthesis squared. Of course, 1 squared is just 1. Secant squared is just secant squared. And now maybe it's a little bit more clear why this is the case. So either way, put a check mark on either of those lines and you're finished.